Okay, so the first thing is I want you to take a look before you get started on your activities today. I want you to look back at what was assigned on Tuesday. And this is not meant to embarrass anybody or build anybody up, but I'm just saying, like, okay, Chloe, look across. Um, she did these things. I don't know why it doesn't put a dot here. Those are the graphs, and just check back. But you got check, check. You're ready to go on today's activity. Hasni, same thing. You're ready to go. Senna, would you go back and look at the feedback sections of that activity from the other day and give feedback on those? I know you went to these screens and then check, check, but do that. Colton, all good. I'm not sure why it doesn't give you those credits, but I saw that you, even though you have X's here, I saw that you were getting most of the stars, so I'm all good. So those four folks, go on with the activity. Other folks, please go back, do this, complete this all the way through the marble slides, and it's pretty straightforward. And then look at the next section that I'm about to go into. So pause it here if you haven't. Otherwise, folks, those four folks I mentioned, go on to this next part. And I hate being out. I think I've said that before, but anyway, when you get to this part, after you've gone back and done the Desmos, if you needed to, I want you to take a look at this. This is the parent function, and this is a transformed, and this is just a summary after you've done the Desmos activity. All right, the parent function looks basically like this. You're not responsible for coming up with where these dots are. You're generally given a graph of this. I just want you to see that. Ooh, I'm working off this little pointing device I got here. I just want you to see that that is the parent function of a log graph, and it is log base 2 of x, and it has nothing extra out here. It has nothing in front of it. That's called the parent function. And the a, h, and the k values, which you explored in that previous Desmos activity, are the things that adjust this parent graph. So the a value, you saw that if a was greater than 1, it caused it to, well, everybody didn't put it in this language, but it caused it to stretch. Okay, and so I'm going over here, and I'm looking at this first thing, and I ask you in this first thing to manipulate the a value. What did the positive values do? And this is a good summary. It changed the curve of the line. It caused a positive curve. The graph gets steeper as it increases. Okay, so these are all in their words. What it does is it stretches. If a is greater than 1, if a is greater than 1, then we get what we call a stretch. If a is between 0 and 1, right, and this is the way we write between 0 and 1, then we get this thing called a shrink. And it causes the graph to shrink up, so to speak, and not have the same curve. And you need to go experience that in Desmos to kind of see it. All right, this stuff should ring a bell with some stuff we did earlier with exponentials, and I want to say there was radical functions, and we're going to see it in our next unit as well. And so any value in front here, if it's a 1, it's just the parent function, but if it's higher than 1, we get a stretch. If it's between 0 and 1, we get this thing called a shrink. By the way, if it's positive out front, then we get, and so I'm going over here to feedback from the one. If you get negative values, then I like this. It's mirrored the line over the y-axis. We'll see more on that. Another one really good. It flipped the line, and some other folks had some different ideas, but it did. It flipped the line. Okay, so when this is negative, we get a flipped version. A flipped version. All right, and so you'll see this one down here is going to be a flipped version. You're going to see that in that graph. If it's a positive, it's just normal. All right, so I don't need to say it's unflipped or whatever, but it's just normal. It's not flipped. All right, the h value, let me jump over here, take a look. This was the h value. Move the graph to the right. Function right or left. Ooh, I like that one. It slides right or left. It just depends, and it moves it horizontally. Oh, all three of those were good. All right, and so this h value, Carlos one time said, take whatever's in those parentheses there, x minus, say, 5, and that is going to, you get this 0 of it, was what he said. And when you set this equals 0 and solve it, you get a positive 5. So it moves it to the right by 5. No. Now, if that was x plus 5, then we would be going to the left 5 because you would set that equal to 0, x plus 5 equals 0, and solve it, and you would get negative 5, so it's going to shift to the left. And then finally the k, and the k is probably the easiest one to deal with. Let's see if I can pull that up here, sorry. The k, okay, so here's a k, the line shifted upwards. Okay, so positive values, it shifted up. And this person talked about it being a shrink or whatever, or stretch, but that's more with the A. I understand it's very hard on these log graphs to kind of see what's going on, but it's the up and down is from the K. So if we have a plus out here, we're going up. If we have a negative, we're going down. Okay, so let's put that into action on this one. You're not going to be responsible for graphing a log function on its own. Let me just show you how this one would work. I want you to note that there's kind of like this one section here at 1, 0 and 2, 1. Those are, so you can kind of hit this 1, 0. This is the parent graph, you know, goes something like that. Well, this transformed one, well, look at here, x plus 2, so it's going to shift to the left by 2 units. So this one's going to go 1, 2, and end up over here. This minus 3 that's on the outside that's not part of the log argument is going to make it shift down 3. So it's going to be over here. So this point is going to be way over here, over 2, and down 3. So this graph is going to look something like this. If it had a number out front that was above 1, it would stretch that value. If it had a value, so here, like if it had a value higher than 1, that thing would stretch it. If it was less than 1 but still above 0, it would shrink it like that. And then if it were negative, then it would flip it. Oh, I can't show that. Then it would flip it. And that's where we are. Okay, so stop there. I know there's more to fill out here, but I want you to go do the Delta Math 7.13. So Delta Math 7.13. Delta Math 7.13. Just the first three problems in that that relate directly to what I just showed you. When you get to question 4, hit the new video.